4 o'clock. Thank you guys for hopping on today or watching this later. Either way is great. I have some stuff that I want to go over just as like overview stuff, but we will also, I will take any of your questions. So send them to me on Remind or send them to me in the YouTube chat. Either of those are totally fine, and this time is about you. So if you have a question as you're working, please send it, because that's why I'm here, so that we can answer whatever you guys have, okay? So on my end, what I thought we could do is go over sort of the 6 big free response types, the big things that you're likely to see, and from there, you'll kind of see what they could ask. This document that I'm going to be going through, minus the actual questions, you got it on your unit overview, but the questions are all released free responses. So if you have questions at any point, these are questions you can go back to, you can Google, you can find, and they will come up. So we're going to start with area and volume. So area and volume is a question that hasn't come up in a couple years. It has been on the secure exam. So again, that's something where if it hasn't been on the test, but it's been on the secure exams, some teachers would argue that we're due for it. They've been asking it in some more creative ways, so we'll look at that too today. But we're going to start by looking at a basic area and volume question, and then we'll move on from there. So on this, if this is on the calculator section, it's important that the definite integral will be evaluated on the calculator, right? We expect that. But you still need to write the definite integral and the limits on your paper and write what the value equals. So make sure that that is there. It's not required that you show what the antiderivative is if it's on the calculator. So make sure that that setup is there. Now, what you need to know how to do. These are sort of the skills that you'll see. Finding the intersection of the graphs and using those as limits, that's going to be important. That could be either calculator or non-calculator, okay? Finding the area of the region between the graphs in the x-axis or between 2 graphs. Finding the volume when the region is revolved around a line, not necessarily an axis, using either disk or washer. Find the volume of a solid with cross sections whose base is the region between curves. And finding the equation of a vertical line that divides a region in a certain ratio. So those are things we're going to look at today. But those are the big things that have often come up in questions. So those are sort of the skills you should be able to do. So this question you've seen before, but this is from an exam semi-recently. I think it was maybe 5 or 6 years ago. So R is this region, and often they'll define a region. And it's bounded by the graph y equals 2 radical x, the horizontal line y equals 6, and the y-axis. And nicely here, they gave you the intersections. Now, sometimes it can be helpful to label these. And I know a lot of us, we can just see it, but, some of us can't. So it's good to label those. And let's see what we need to know. So first thing is find the area of R. So I'm looking for this area in here. Remember that area is going to be the integral between your bounds of the top function minus the bottom function, or right minus left if you're going with respect to the y-axis. And so this is going to be the integral from 0 to 9 of 2 radical x, or I'm sorry, that's not the top. The top is 6 minus 2 radical x. And so that would be my area. Now, I am not done there. So a lot of people will do that and be like, boom, done. It doesn't say write but do not evaluate an expression for this. So we actually need to find that antiderivative. You would say, okay, antiderivative of 6 is 6x. Antiderivative of 2x to the 1/2 would be 2, and then you could do x to the 3/2 times 2/3, or 4/3, and then this would go from 0 to 9. Now you could plug in those values and be done there. So you could do 2, or we could make this 4/3, you could leave it as 2/3, and then 9 to the 3/2, and then minus 0 for that whole expression, or you could do 0 times 6 minus 4/3, 0 to the 3/2. And this is a fine way to leave your answer. Remember, you don't need to simplify from there, but do not just leave it in this phase, which a lot of people will tend to do just because they're rushing. That is a non-calculator question. Notice the integral wasn't super hard, right? All right, next one. B, write but do not evaluate an integral expression that gives the volume when R is rotated around the horizontal line y equals 7. So first thing I would do is really sketch this. Excuse me. So y equals 7 is up here, And notice that's going to leave a gap between where your region ends and where your line is. If you actually rotated that around, you would wind up with this sort of shape and that sort of shape. And you would have sort of a cylinder going through the middle and then a bell sort of shape on the sides. So this is definitely a washer. Now, remember with a disk, you're just doing the area of a circle, which is pi r squared, right? But with a washer, you're doing the area of a washer where you need to do outer radius squared minus inner radius squared. Washer, we're going to need to do that. So this is the integral from 0 to 9 of pi times your outer radius squared minus your inner radius squared. And let's think about this. So the bigger radius here would be going from my center to that line, right? So that would be 7 minus 2 radical x. The smaller radius would be the cylinder, which would be going from there to right there. And that's 7x. Now, you could also just say that that's 1. It's the same thing. So this is your radii in there. And then you still need the dx at the end. So that would be a complete and correct answer for B. Right, but do not evaluate an expression for that. Now, if I look at C, it says region R is the base of a solid. For each y is between 0 and 6, the cross-section taken perpendicular to the y-axis. So now notice we're slicing this way. So the width of each slice here would be dy or delta y, so that's going to matter, is a rectangle, so I have rectangles coming up out of it, where the height is 3 times the length. So actually it would be a pretty tall rectangle. Now, right, but do not evaluate an integral expression for this. So the area of a rectangle whose length is 3 times its height would be 3L times L, right? Length times height, 3L times L, or 3L squared. So the thing you're taking the integral of is 3L squared, but we just need an expression for L. So let's look at this here. The actual length of this goes from here to here. This is y equals 2 radical x, but since I'm doing this with respect to y, I'm actually going to solve this for x. So y over 2 equals radical x, so x equals y over 2 squared. And then this is x equals 0. So your actual length is y over 2 squared minus 0. And so we're going to do 3 times that squared. The integral, I've got a dx here, or dy, excuse me. And let's look at my bounds now. So since we're talking about y values, we're going from 0 to 6. And so this is about as basic as an area volume question will get, right? That's about as straightforward as they will get. Now, they can ask them in kind of stranger ways, and I want to look at one, and we're not going to do the whole thing, but we're going to sort of look through what this one asks. So this is a hidden area volume question, and it also has a related rate in it. But you see in here, it's asking you to find the volume. And this is a question that caused a lot of panic in, I think this was 15 maybe. So find the average value of the inside of a funnel of height 10 has circular cross sections. So I'm immediately thinking the cross sections are pi r squared, as shown in the figure. At a height h, the radius is given by this. The units of r and h are in inches. So find the average value of the radius. Well, they gave me a formula for radius, so I'm finding the average value of that. So this would be the integral, it would be 1 over 10 minus 0, the integral from 0 to 10 of 1 over 23 plus h squared dh. We're actually going to integrate that. And again, I would integrate that all the way out. I'm going to assume, for the sake of time here, that you can integrate that out. I would just distribute this and then go from there. But average value, remember to use the average value formula, right? B is where it got really tricky. So B said find the volume, and everybody went, wait, that's kind of a cone. I don't know a formula for a cone. My teacher said they'd always give me the formula for a cone. What do I? And that's because this is not a cone. Unless they specify that it's a cone, don't assume it is. It's not. It's curved, right? And there is not a formula that you need to have memorized for volume of a funnel. So what you needed to think about here was that this was really something with cross sections that were all circles. And if I accumulated all of those cross sections up, it would give me the volume. So really what I'm doing is knowing that volume is the accumulation of area, right? If you know that, then you're good here. So what I would say is that volume is the integral from 0 to 10 of the area, which is pi r squared. Now, we have a function for r, so I can plug that in. dH. And now I have a way to calculate that exact value. So remember that not all cross-sectional area problems have to look like they did in C. They can also look like this, where they tell you the cross-sections are a certain shape, and then you could go from there. All right, and then the last thing was part C. This was a related rate. The funnel contains liquid that's draining from the bottom. At the instant when the height is 3, the radius is decreasing at that rate. At that instant, what is the rate of change of the height? Again, not a cone. You could just use the formula that they gave you right here and then take the derivative with respect to time. So that, in general, is what I would say are good baselines to know for area volume. Again, we haven't had one in a while. Important that if we, it's something you look over and don't just gloss over and say, oh, I don't think it'll show up this year. Okay? Send questions as you have them. Again, this is your review wisely. Okay, second one is particle motion. These questions may give the position, velocity, or acceleration. You can be asked about the motion in a direction, in both directions, its maximum, its minimum, all of this stuff. Particles can be people, cars, bikes, bugs, whatever, and you can be given them as graphs, equations, lots of different things. Things you might be asked to do, okay? So you might be asked to solve an initial value differential equation problem. So I might give you velocity, give you an initial condition, and ask you to find me the position, right? So to work backwards and integrate. You might be asked to distinguish between displacement and total distance. So an important thing to remember there is displacement is your change in position. Distance is the total distance you've traveled. So adding up all your changes in position. Here's what I would say to remember. Total distance is the integral of your speed, right? Which is the absolute value of velocity. Net distance is just the change in velocity. And the final position will always be initial plus net change. And you know that, we've done that a lot. To find speed, we are going to either take the absolute value of velocity, so find average speed, velocity, acceleration, whatever. Determine if speed is increasing or decreasing, or if something's speeding up or slowing down. You would look at velocity and acceleration having the same sign. And you can also use a difference quotient, right? Finding the average rate of change. A Riemann sum, units of measure come up a lot in here, in interpreting the meaning of a definite integral. So those are sort of all the things you might be asked to do. We're going to look through a couple of these and see what these sort of look like. So a standard one and then one that might be more tricky. So this first one, t is greater than 0. A particle moves along the x-axis. Velocity is given by this. And the particle is at this position at t equals 4. Immediately, this should scream out to you that that's an initial condition. And so that tells me that at some point I'm probably going to be finding its position using that. So part A, is the particle speeding up or slowing down? So in part A, I'm looking at t equals 4. I would find v of 4, which you could just plug in, and this was calculator active. And then I would find v prime at 4. And what I would look for is if those have the same sign or if they have a different sign. If they have the same sign, we'd be speeding up, both positive or both negative. If they have different signs, then they're slowing down. And so that's something that's important to remember, speeding up or slowing down, okay? For the next one, find all times where the particle changes direction. So particles will change direction whenever v of t changes signs. Now this was calculator active, so all I would do for B is look at the graph and see where it changes signs. Sometimes that will take you some time to play around with your zoom. Just be patient, zoom in, zoom out, use your second calc, whatever. Make sure everything goes to 3 decimal places. And if it says justify your answers, that doesn't mean necessarily that you need to do a ton of crazy work, but show me the equation and then tell me that that's where it changes signs, right? Okay, C, find the position of the particle at t equals 0. Oh my goodness, what a surprise. We got an initial value problem. So to find that, I am going to do net change. So my initial will be the position at 4, which is what I know. So 2 plus the change from 4 to 0 of v of t dt. And again, put this in your calculator, get a value. But remember that we're starting at t equals 4, so we have to go backwards from 4 to 0. And then D, find the total distance. So total distance means we're not just looking for the displacement. I don't just want the net change. So this would be the integral from 0 to 3 of not just v of t, because that would be the displacement, but the absolute value of v of t dt. Because absolute value is going to get rid of whether it's positive or negative and just look at the actual movement you had. And so for that, again, you can just put that in your calculator, go to math and then absolute value and go from there. So again, send questions as you have them. So let's look at the next one. Two particles moving along. Position of particle P at time t is given by that. The position of particle Q is given by that. Particle Q is at position 5 when t equals 0. So I see for particle Q, I have an initial. So when is particle P moving left? So this is going to happen when the velocity of P is negative, which would mean x prime of P is negative. That's what I'm looking for. Now this was calculator inactive, so actually taking that derivative, x prime P of t would be 1 over t squared minus 2t plus 10 times 2t minus 2. Remember, we're multiplying by the derivative. And I need to find the critical values of this. So finding critical values of this, I'm going to look at where the numerator equals 0 and where the denominator equals 0. Numerator here will equal 0 at 1. Denominator will not equal 0 over the real number system that we're dealing with, not on our interval, because we're never going to have that. So here I'm just looking at either side of 1. And now I'm going to plug into x prime. So that would give me, let's see, to the right of 1, let's say I plug in 2. That would give me 4 minus 4 plus 10 on the denominator. And so this would be positive. And if I plug in 0, I would get negative 2 over 10, which is negative. So particle is moving left anywhere from, they gave me a domain, right, from 0 to 8. So from 0 to 1, right, particle is moving left. Now for B, where will the two particles travel in the same direction? So which way particle P is moving, right, xp. And again, you'll have a lot of space to stay organized. Here I'm a little smushed because I didn't leave myself enough room. So let's look at the velocity here. And notice this is already the velocity of Q. So V of Q equals 0. So that would be t squared minus 8t plus 15. And so I'm going to have t minus and t plus. And so this would be, or no, actually minus and minus. Minus 5 and minus 3. So this will have critical values at 3 and at 5. And this will go plus, minus, plus. It's a quadratic. It opens upward. So when will they be traveling in the same direction? So here, and I sort of like to think about this, lining these up. So if you think about it, 1 would actually be over here, right? And so this would be negative here and then positive there. So positive, negative, that doesn't work. Negative, positive, that doesn't work. So here, from 1 to 3, those would have the same sign. And then from 5 to 8. So I would say from 1 to 3 and from 5 to 8, wherever those would have the same sign. Okay, part C, find the acceleration of Q at t equals 0. So you time of Q, which would be 2t minus 8, and v prime q of 2 is 4 minus 8, which is negative 4. And so notice that my velocity here is negative. My acceleration is positive, so this is slowing down. And you would explain again, because velocity is positive at 2 and the derivative of velocity or acceleration is negative, then this would be slowing down because they have opposite signs. And then find the position of Q at the first time it changes direction. So the first time it changes direction is at 3. And so you're going to use the 3 and go from there. Or actually, they gave me initial at 0. So I would say 5 plus the integral from 0 to 3 of VQ of t dt. And again, you'd actually integrated that. I'm just not doing it for time's sake because we've got 4 more topics to get through. Okay, any questions, please send them. You, this is our moment. Send away. Okay, next type is interpreting graphs. These come up a ton. They can be particle motion. They can be all sorts of different things. But normally they have to do with curve sketching. So things you're going to need to be able to do. Read information about the function from its derivative. So think about increasing, decreasing, concave up, concave down, all of those things. Find and justify extremes. So it could be that you're finding relative extrema, which would be first or second derivative tests, or you're finding absolute extrema, which would be your candidate tests, right? Look at your endpoints. We could need to find points of inflection, which are where the second derivative is 0 or where the first derivative changes signs. Finding an equation of the tangent line. The slope of the first derivative changes signs. Equation of a tangent line, Riemann sums, evaluate the integral from areas, realize that we have initial plus net change, knowing that the derivative of an integral is that function, and knowing that we have a family of functions. So let's look at how these sometimes appear. So here we've got this. We know that the function g is defined by being the derivative or the integral from 2 to x of f. The first thing I do when I see this in the very first section, I would say that means that g prime equals f of x. And that's because it's really plug in your upper bound, right? Times 1 minus plug in your lower bound, which is 0. So you don't need to write that out, but again, that's fundamental theorem. That's something good to review. So your derivative of that integral defined function is f. So when I look at this, I'm reminding myself that this is also g prime, right? Keep that in mind as we work here. So does g have a relative min, relative max, or neither at 10? Justify your answer. Well, at 10, remember that this is g prime. For it to have a relative min or relative max, g prime would need to equal 0, which it does, and g prime would need to change signs, which it does not. It goes from negative to negative. So this is neither, and we would say because g prime, which equals f of x, doesn't change signs at x equals 10. So justify, make sure you explain that. Does the graph of g have a point of inflection at 4? So there's that point. Let's think about it. Point of inflection would mean g double prime changes signs, right? That's what that means. And I'm just kind of writing my thinking out, which means that g prime's slope would have to change signs. So g prime goes from a positive slope to a negative slope. And so I would say yes. And you could say a couple different things. You could say f has a relative extrema. Or you could say the slope of f changes signs. And I know I'm really squishing this in. Okay, next part. Find the absolute max and mins. So this should signal candidate test for you. It should make you think about Wolf Blitzer and Jeopardy. So absolute max, absolute min on the interval -4 to 12. So here's what we need to think about. We need to think about our endpoints. So first of all, -4 and 12 need to be in there. And then we need to think about the critical values, which would be where g prime equals 0. So g prime equals 0, that's f, at -2. At 2, I know that's not a max or a min, so that's not really a candidate. You could put it in your table, but you don't have to. At 6, that's definitely changing signs. And again, at 10, it's not a max or a min, so you don't really need to worry about that. And now I know these are the x values I care about, so I'm going to find g of those values and see where the actual max and min is. So remember here that g is the integral from 2 to x. So I'm going to find the integral from 2 to negative 4 of f. And let's see what that is. So going from 2 to negative 4, I've got this whole area. And that is 1/2 of 4 times 4, so that's 8. I've got this area, which is negative 4. And actually, we're going backwards, so I would do negative 8 plus 4. So that is negative. Now, g of negative 2. So I'm going from 2 to negative 2. That would just be negative 8. G from 2 to 6. So this would be from 2 to 6, that's 8. And from 2 to 12, well, these cancel each other out, right? And then I've got 2 times 4, which is 8, divided by 2, which is 4. And so that is positive 4. Or I'm sorry, negative 4. So notice what we have here. The absolute min is negative 4, and the absolute max is 8. And notice it does not say where they occur, it says what they are, right? And justify, this table counts as justifying, as long as we know that we're looking at those as your candidates, right? So normally the points come from identifying your candidates, looking at the endpoints, and evaluating. All right, the last one is find all places from negative 4 to 12 where g is negative. So what that would mean is that the integral from 2 to x of f of t dt is less than 0. So this one you can kind of think through just through some geometry. So if I go from negative 2 all the way to there, well, that's negative 8, right? And then we're adding 4 more, but that's not becoming positive. So for D, the whole interval from negative 4 to 2 would be negative. Now, if I go to the other way, this is positive, right? That's a positive area. Now I'm canceling all that out till I get to there, which is 0. And then it's going negative. So G is negative here from 10 to negative, to. And again, it's through logic and looking at the areas. Okay, let's look at this last one. Let's just make sure there's nothing weird in here. So talking about where something is increasing. Okay, so finding these values. So here they don't tell me, they just tell me this is f prime, but they do give me an initial value. So f of negative 6 should be your initial value plus the change from negative 2 to negative 6 of f prime. And same thing for 5, it should be 7 plus the change from negative 2 to 5 of f prime. And you would again actually evaluate those using area. On what intervals is f increasing? That would mean f prime is greater than 0. So this would be from negative 6 to negative 2 and from 2 to 5. Absolute min would be exactly what we did before. And make sure you're saying the min value. And f double prime of those values. So you're looking at the slope of this. So f double prime at negative 5 would be this. You would just find the slope of this portion, which is down 2 over 4. So this is negative 1/2. F double prime at 3 is, well, that's that point, and that does not exist. And it says explain why. I would say f prime is not differentiable because there is, at x equals 3, because there is a corner. Okay, so questions on those. Send me questions. What do we got? Okay, next one, accumulation and rates. You guys are experts at these. We're not going to take a lot of time on these. But the big thing to remember here is initial plus net. Know that it's often not necessary to do as much computation. Often they'll just say write an expression or something like that. So remember, we may use the fundamental theorem. Often these have a lot of writing. Just make sure that you're putting in units, that you're recognizing that the rate is the derivative. Recognize rate from the units, right? And so looking at like meters per second, anything with a per. Explain the meaning of a derivative or a definite integral, in-out problems, min-max, increasing, decreasing, and more explaining. So I just want to look at this one. You guys pretty much are killer at these, but there's some things we can look at. We're not going to do the whole thing, but just some things to point out. So when a certain grocery store opens, it has 50 pounds of bananas. Initial, boom, I'm seeing that. This is the rate they're being removed. It's often good to label that. And notice that's from 0 to 12. That's in pounds per hour. Boom, that's a rate. Okay. The store has been open for 3 hours. They begin to add bananas. And this is big here. Look at that domain. Okay. This is only from 3 to 12. So when we calculate this, you've got to be careful. You're going to be removing from 0 to 12, but you're only adding from 3 to 12. So how many pounds of bananas are removed? This only cares about F, right? And the first 2 hours, so I would do integral from 0 to 2 of f of t dt. And this is for sure a calculator question. So show that integral and then write your answer to 3 decimal places. Now, find f prime of 7. You better plug that into your calculator. So f prime of 7, please don't do that by hand. Using correct units. Well, f prime, we know is pounds per hour. So this would be pounds per hour per hour. And you can write it as pounds per hour squared, but I often feel like it will help you to write it this way as far as explaining. So what this would mean is that 7 hours after the store opened, that's an after, store open, the customers remove bananas the rate the customers remove bananas. The rate the customer remove bananas is increasing by that number pounds per hour each hour. So it can help to think about pounds per hour is the unit of f prime, and it's doing that each hour. Okay. Now, is the number increasing or decreasing? Well, let's look at this. The rate they're being taken away and the rate they're being added. So I'm going to do G prime. I'm going to find F prime, and I'm going to compare those, see whether more are being removed or added. The other thing you can do is subtract, add, minus, remove at that time, and you can see whether it's positive or negative. And then D is the big one. How many pounds of bananas are actually on the display? Initial plus net change. The problem with the net change is we are adding them from 3 to, and we're taking them away from 0 to 12. Or I'm sorry, this is 8. So just be careful with that. Just look at your bounds. Otherwise, I really think you guys pretty much nail these questions every time. Okay, more questions. We've got 2 more quick types left. We're going to breeze through them so you can get on with your thing. Anything? Okay, so topic 5 would be things that are given from tables. So this can be almost any type of question. It can be function analysis, accumulation, position, velocity, acceleration, MVT, IVT. You can get it all in here. So these are ones that are very versatile, and you'll definitely see one. Approximate derivative, right? Find the average rate of change. Riemann sum or trapezoidal sum, average value or MVT, roles, all of those. Now, here, this. If I could put blinking stars around this, I would. We never in our class have ever done a regression equation. Never. Okay? You will not be given a regression equation on this test. Do not try to use a regression equation. It is not going to come up. Okay? So we're going to look at one in particular. This was a interesting one. And this gives us our table, right? So using a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon and 8 p.m. The number of entries in the box after noon is modeled by this differentiable function E. And the values, and I want you to underline this if you see this, in hundreds at various times is shown. When you write an answer, if you get 14 out as an answer, you need 1400, right? So make sure that that's in there. Okay, that's important. Now, using data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at t equals 6, show the computations that lead to your answer. So I want the rate, that means I want the slope. I'm looking between 5 and 7, and so I would be doing e of 7 minus e of 5 over 7 minus 5, and that I could put 21 minus 13 over 7 minus 5, and you don't need to simplify any more from there. That is as far as you need to go, but you should put in hundreds of entries per hour. If you have the units, throw them in. It's never going to be wrong to make sure they're there. Okay, for B, use a trapezoidal sum with 4 subintervals given by the table to approximate this. Now, if it was just an integral, it would be the net change. But notice that my bounds are 8 apart from each other, and that is from 1 to 8. So we need to think, hey, that's the average value formula. So I'm going to write what this is first, and then we'll do the actual sum. So this would be the integral from 0 to 8 of e of t dt is the average number of the average value of e. And e is entries, right? The average number of entries in the box in hundreds of entries 8 hours after noon. Or you could say at 8 p.m. There's lots of ways you could say that. Now, actually calculating it, remember we have uneven intervals and you're doing a trapezoidal. So from 0 to 2, that's 2 wide. So I'm going to do then average the y values. Plus from 2 to 5, that's 3 wide. Average the y values. From 5 to 7, that's 2 wide. Average the y values. And from 7 to 8, that's 1 wide. Average the y values. And please do not simplify that, okay? You don't need to. Leave it alone. It is the way it is. All right, at 8 p.m., volunteers begin to process the entries. They process them at a rate modeled by this. So, according to the model, how many entries have not yet been processed? So, we need to think about here the total number of entries that were in the box, right? So, 2,300 entries in the box. And we're going to subtract out the number that have been processed, which would be the integral from 8 to 12 of p, because p is already a rate. Now this you'd actually calculate and then subtract those. You don't need to actually do the subtraction, right? And according to the model from Part C, at what time were the entries being processed most quickly? So you would look at p of t, the rate they're being processed, and you want to find the maximum of this. So you'd look at p prime of t, and then find where it changes from positive to negative to find the max. Okay. Last type, unless you guys can send me some questions, and I've been drilling you on this type of question because we've had some really tough ones. So we are looking at differential equations. Differential equations are tested every year. It's not always the actual solving, although typically it is, but it's normally accompanied by a slope field, a tangent line approximation, something. So let's look at things that could be asked. You could be asked to find the general solution, separate your variables, separate, integrate. Those are like 5 points. So make sure that you show each step, and we'll talk more about what those should be. This is the only method you'll be tested on. So if you can't separate it, then it's not a separation question. You're not going to be able to find it. Okay, finding a particular solution using an initial value. So actually solving for C. Growth and decay problems. Remember, if you see y equals, or dy dx equals ky, or if you see that something is directly proportional, then you should think about y equals ce to the kt. That typically is in the multiple choice, but could be a free response. Slope fields, if you get a slope field, you better get that whole thing right because those are easy points. Sketch a particular solution curve, again, easy points, and interpret. And I have a whole live stream about differential equations and slope fields. So if that's something you feel like you need more review on, there's one just on slope fields and one just on differential equations. So go back to those. Okay, so we're going to look at 2 questions, weird things they might ask, and we'll go from there. So consider this differential equation. So A on the axis provided, they will always provide you axes and it will have points. Sketch a slope field for the given differential equations at the 6 points. You're only going to do it at the 6 points. So I'm not going to do it for all of these because I forgot to copy the graph. But let's say I asked you to do like 0, 0, 1, 1, and 1, 2, right? So those are the 3 points I asked you about. So if I do that, I'm going to do dy dx equals y squared and then x minus 1. So I'm going to plug in 0, 0. That would give me 0 over negative 1. So this would be a slope of 0. So at that point, make sure it's 0. Normally they grade these as 0 slopes and non-zero slopes, separate points. So make sure it looks like a 0 slope. Now next one, plug in, let's say we're doing this one, 1, 1. So that would be 1 over 0. That would have no slope, so you would leave it blank. Undefined. Same thing for 1, 2, right? So let's pick another one because I picked bad points. So let's say that we do 2, 1, that point, right? So now if I plug that in, I would have 1 over 1. And so just approximate a slope of 1. Think like up 1 over 1. That's about that slope. So just approximate it. They're not looking for it to be perfect. All right, B, let y be a particular solution. Read this carefully. Let it be a particular solution. It does not say find a particular solution, right? Be very careful. Write an equation for the line tangent to the graph at 2. So we know we need a point, which they gave us, and we need a slope, which they gave us. So this is going to be y minus 3 equals something times x minus 2. This needs to always be a number. Slope is a number. So please don't ever put an expression in there. And we know this point, so plug that in. So this would be 9 over 1. And so that's your tangent line. And use this to approximate that at 2.1. So y minus 3 equals 9 times 2.1 minus 2. 9 minus 3 equals 9 times 0.1. Or y minus 3, sorry. So y equals 3 plus 0.9 or 3.9. You don't have to do that. You could leave it as 3 plus 9 times 2.1 minus 2. And that would be correct. All right. And then C says find the particular solution. And that is when you're actually going to separate and integrate. So if I was doing this, and I'm just going to, actually do this. So separate, integrate. So I'm going to divide the y over. So I have 1 over y squared dy equals 1 over x minus 1 dx. Remember that not everything is an ln. It has to be the first. So this is really y to the negative second. And integrate both sides. So this would be negative 1/3 y, or I'm sorry. I went the wrong way. This would be y to the negative first with a negative out front. This side, because this is to the first, you could do a u sub where u is x minus 1, and then you'd have the integral of 1 over u du. And so this is ln absolute value of x minus 1 plus c. And so I've got y, 1 over y is negative ln absolute value x minus 1 plus c. So y equals 1 over negative ln absolute value x minus 1 plus c. Now I want to solve for that point. So I could say, okay, 3 equals 1 over negative ln of 1 plus c. That's 0. And so c here would have to be 1/3. So then your solution would be y equals, and it actually says f of x, so you could do f of x equals 1 over negative ln, absolute value of x minus 1, plus 1/3. You don't need to simplify more. Okay, Cool. So last question that I have planned, and then if you guys have questions, send them to me. What weirder, right? So here's a landfill one. This is, I forgot from what year. I think maybe 2011. But at the beginning of 2010, a landfill contained 1,400 tons of solid waste. Boom. Initial condition. An increasing function W, so that may be important, models the total amount of solid waste stored. Planners estimate W will satisfy this for the next 20 years. W is tons, T is in years from 2010. So A, right aligned tangent. So I would say here we're pretty good, other than if we know that a T equals 0, you have 1,400. So as long as you can pull that out of the problem, you're just writing a tangent line. Same as above. Now, part B is one we didn't see above. So it said here, find d squared W over dt in terms of W. That means no derivative in there. It's all got to be W's and T's. And use this to determine whether you have an overestimate or an underestimate. So let's do this. dW dt is this. So d squared W dt squared. And what I want you to remember here is that W is sort of like your Y value, right? So when you take a derivative of that, you're going to need a dW dt. So this would be 1/25th, but you need a dW dt there because you took a derivative of W, which is like your Y value, right? And then 1/25 times 300 is just a constant, so that's just 0. Now, they want this in terms of just W, so I'm going to do 1/25 times 1/25 W minus 300. And that's fine. You don't need to simplify that. And use it to determine whether this is an over or an underestimate. Now, here's what I know. This is increasing, which means that this dW dt is greater than 0 because W is increasing. And so because of that, d squared W dt squared is always going to be positive. So what that tells me is my second derivative is positive. This is concave up. That means the tangent line will be an under approximation. And I want to include all of that in there, concave up. So I know that it's always concave up because I know the first derivative is always positive. And so because of that, it's an under approximation. Now, part C, find the particular solution, and they give you that point. And notice here in part A, if you hadn't seen this, they give it to you in part C, so it's never a bad idea to look ahead if you're getting stuck. But I'm going to make this a little smaller, and I'm not going to do this whole separation of variables. If you get stuck on it, message me, but I think you guys are okay with this. But what I would remember here is that I want the W with the dW, but I want everything else away from it. So I'm just going to bring the part with the W over because I want to make the side that I have to solve for as easy as possible. And so the less I have to get rid of in the long run, the easier. Now, that's separated. Integrate both sides. So this is just 1/25th T. This side, because that's just to the first, is ln W minus 300. And I guess I am doing this. Now I could plug in here to get that value for C. And I'm going to leave that to you guys. But solving this, remember that this would be Y equals, I'm sorry, not Y. This would be W minus 300 equals C e to the 1/25 T. And then W would be C e to the 1/25 T plus 300. And you could also solve for C there, which I'm just going to do because it's going to bother me if I don't. Because that's... Okay, so guys, those to me are the 6 major types that you'll see, right? So let's quickly scan through them again. And we did a lot in the last 50 minutes. So we did area and volume, particle motion. We did looking at graphs and curve sketching, accumulation and rates, tables, and different... Now, there are other things, but I wouldn't like major types. So then other types. So definite differentiation, those can definitely pop up. Ask you about second derivatives or first derivatives. They will ask you about knowing how to evaluate them by subbing in points, analyzing the derivative, and working with tangent lines. Those come up a lot. They will use product quotient or chain rule, and they can use U substitution. So make sure that you are looking at those. Related rates, again, they don't come up, on every single question, but they do come up every single year. And make sure you know how to differentiate using product quotient or chain, set up and solve related rates. And make sure that if you're looking at something and you feel like you don't have enough information, that you know how to simplify, right? That you know how to get something in terms of one variable. Think about a funnel question and go from there. You guys know so much. You are seriously so prepared. And I just want you to put in that work so you make sure that all your hard work pays off. And I will see you guys Tuesday. If you have questions, come see me. And I hope you guys have a wonderful weekend. Thank you for tuning in. And I will hang out for another couple minutes for questions. So send them along. I'll stay for, a couple minutes if people don't have any. But I'm just going to wait here and see what you ask.